Okay, here we are, 16.3. We will review tomorrow, test the day after. Today we are going to graph. Tomorrow, well, I'm going to tell you a special story about Doc Sauer in a minute, but no, it has to wait till the right time. No, the time is later. What the heck? You're totally screwing up my episode of 16.3, Math Life, Math Muscle. Yeah, come on. Totally messed it up. Now I have to redo it 6th hour. Stop. Okay, let's get this started. I would like you in the next 4 minutes to do, let's see here, either 1 and 2 or 3 and 4. Or if you can get them all four done, then do that. Okay? Pick 2, either 1 and 2 or 3 and 4. You've got 4 minutes. Yep. I'm going to record number 1 here. I drew a triangle. Here is theta. I used Pythagorean theorem to find the hypotenuse, which is 10. Someone will screw up Pythagorean theorem there. They will. Don't screw it up. Okay, so 5 squared is 25. 5 root 3 squared is 75. I add those together, I get 100 to take the square root. I get 10. So r theta would be 10 comma this angle. That angle may or may not be recognizable, but I'm going to divide everything by 10. And that gives me a 1/2 here. That gives me a square root of 3 over 2 here. That makes theta pi over 3. Ciao. Okay, number 3, similarly, number 3, if I extend 40 up to here and rotate, and that's a 40, and I know this angle is pi over 3. Remember, that makes this side 1/2, and this side root 3 over 2. So that would be 20 root 3 over 2, which I could simplify. Hi. Oh, whoops, hold on. Nope, my bad. That would just be that side times root 3. Awesome. So the rectangular coordinates for this, there you go. Nice backpack. See ya. 20 root 3. You could always check that by going backwards. See if you get the same polar coordinate. All right, problem number 2. Let's do this together. We got 2x equals 5y squared plus y. 2x equals 5y squared plus y. I'm going to do substitution. This is 2 times r cosine theta equals 5 r sine theta squared plus r sine theta. Okay, let's see what happens here. This would give me 2r cosine theta equal to 5r squared sine squared theta. Let me take a moment here. Okay, let's subtract the r sine theta. Okay, so I get 2r cosine theta minus r sine theta equal to 5r squared sine squared theta. Okay. Now what? Thoughts? Let's divide by r sine squared theta. And actually, while we're at it, let's divide by 5 as well. Let's divide by 5r sine squared theta. All right, because what will I get then on the right side? R. Yeah, that's what I want. So on the right side, if I divide each of these individually by 5r sine squared theta, 5r sine squared theta, what would this become? 2/5. R's go away. I get cosecant theta, cotangent theta. Yeah? Okay. Minus 1/5. What do I get? One of these signs cancels with that one. Cosecant theta. Now, you could leave it in that form if you wanted. The other way you could do this is you could go ahead and factor out what? Cosecant theta, which would leave you with 2/5 cotangent theta minus 1/5. Either of those two would be, this would be like a difficult R3 slash R4. Like this is pretty extreme. If I were to turn this into rectangular coordinates, you may or may not believe me yet, but this is what it would look like. X minus 3 quantity squared plus y squared equals 9. Okay, if I did the conversion from polar to rectangular, that's what it would be. And that's a circle. With me? What's the radius of the circle? 3, right? The square root of 9. That's the radius. The radius of the circle is 3. Where is the center of the circle? 3, 0, right? I shift to the right 3 and up or down nothing, right? So the center of our circle is here. And we said that the radius of the circle is what? 3. Okay. Am I recording? I am recording. That's good. Good for children on the web. Okay, so if I were to draw a circle of radius 3 from that center, it would look kind of like this. Agreed? And it would, in general, pretty good. And I practiced that all night last night. Not really. Oh, that looks like a deformed jelly bean. That's okay. Okay, so now what happens is this, is I am going to plug in values from 0 to 2 pi, which would be one cycle of 6 cosine theta, correct? So if I plug in values from 0 to 2 pi, specifically values I know, like pi over 6, pi over 4, pi over 3, pi over 2, and then I continue to go around the unit circle, right? I'm going to form this circle. Watch how cool it is. So if I plug in 0 for theta, what is cosine of 0? 1. What is 6 times 1? 6. So if I have an angle of 0, I have a radius of 6. So what does that mean? I extend 6, and I rotate how many? 0. Okay, so I'm going to extend 6. Oh, no. Okay, get away from me, red one. I'm going to extend 6 and rotate 0. That's the first point on my circle. Okay, get ready for awesomeness. No. Okay, if I plug in pi over 4, what is the cosine of pi over 4? Well, it's root 2 over 2. If I multiply that by 6, I get 3 root 2. So what do I do next? I extend out 3 root 2. Well, what is the value of 3 root 2? It's like 5 point something. So I'm going to extend out 5 point something and rotate how many degrees? Pi over 4. That's not pi over 2. Watch what's going to happen with pi over 2. Get ready. What's going to happen with pi over 2? When I plug in pi over 2, what's the cosine of pi over 2? 0. 6 times 0 is 0. So if I extend out 0 and I rotate pi over 2, it's not moving. It's going to stay right at the origin. Okay, let's go to the next one. 3 pi over 4. We can agree, okay? That's what we get out, negative 3 root 2. So which way are we extending? Left. Oh, gosh. I'm extending left about 5, and then how many degrees am I going to rotate? 3 pi over 4. Check it out. Get ready. I'm forming the circle. Say again? Mm-mm. Because this is a little bit over 5. All right, that's the radius. Okay, let's keep going. What's going to happen? Now what's going to happen? It's going to repeat. Well, wait a minute. No, it doesn't, because that's -6. Watch. I extend out -6, and then I rotate how many? Pi. Isn't that cool? Some of you are like, I don't even know what happened. Okay, here's what happened. When theta was 0, we were here. When theta was pi over 4, we were here. When theta was pi over 2, we ended up here. When theta was 3 pi over 4, we ended up here. When theta was pi, we ended up there. We're just going to repeat this. What would be next? 5 pi over 4. Then what? Oops, 3 pi over 2. 7 pi over 4. And then we get all the way back to 2 pi. So we've hit all of those points. Now, if I picked angles that weren't recognizable, it'd just fill in everything in between. So it forms a circle of radius 3. All right. Some of you... Calculator, if you're in polar mode, please get there. I think I'm in polar mode. Yes, I am. I want you to type 3 sine of theta over 2. Listening is a good thing. Theta over 2. In R1, oh my gosh, are you kidding me? Get into, what the heck? Okay, 3 sine theta over 2. Okay, that'll be my blue graph. And then 3 cosine theta over 2. Okay. And I'm going to go to my window so at least I can see everything. It looks like my y values, I want to go -10, and I'm going to graph that. That's my blue graph. That's my red graph. Yeah, those are hard. Okay, so this, the blue one. Let's erase the red one for a moment. Let's erase this. Okay, this is calculator language. So if you're not listening, you'll have no idea how to do this, and that's up to you. That's fine. Okay, if I want to shut off a graph, I just unhighlight its equal sign. I graph it. This right here is called a cardioid because it kind of looks like a heart, a little bit, right? It's kind of weird. Yeah, it's turned to the side. Okay. But this is called a cardioid. This piece, if I go back here, and I'm going to take that graph off and turn this one on. This is, if it were to complete, and you'll see why in a little bit, but if it were to complete, it would do that. That's called a lemicon. Sure, a leprechaun. That's a lemicon. Okay, and here's the Doc Sauer story. He'll get some credit on the tube. Maybe even get me some, financial gains due to multiple views or thousands. Even though I don't need it. 300K hashtag. Okay. Doc Sauer said that one day, while he was teaching polar functions, he was eating cereal, and he saw a lemicon in his milk. He said the reflection of light into the milk, because he was almost done, he saw a lemicon. So, yeah, he was like really excited. So the next day, he made everybody bring a spoon, and they had cereal in class to see if they saw the lemicon. So tomorrow, I want you to bring a spoon. And I want you to buy a 25-cent milk. Is it still 25 cents? It's 50. What? Okay. At the cafeteria, I want you to get a little. Oh, if they're free, I'm getting 8 grams of protein with that chocolate milk. I'll tell you that. Okay. But Bring a little carton of milk, and I'll bring the cereal. Okay, I'll probably bring something with cartoons on it. Unless anybody has an allergy, let me know. I'll bring some stuff, and we'll have cereal. Let's go ahead and do this cardioid. 3 minus 3 cosine theta. Type it in. Three minus 3 cosine theta. Hey, there's a cardioid, right? What would happen, do you think, if I did... Ooh, let me get rid of this sketch here. What if I did 3 minus 3 sine theta? What do you think would happen? Leprechaun? You think it'd be a leprechaun? Let's see. So let's go 3 minus 3 sine theta. Oh, it's that way. What if I did 3 plus 3 cosine? The other side, right? So let's do 3 plus 3 cosine. Let's go 3 plus 3 cosine. And 3 plus 3 sine? 10 to 10. I think a negative 10 to 10 in both directions. Oh, no. Oh, I screwed it up. So I need 3 minus 3 sine. No. 3 minus 3 cosine. 3 minus 3 cosine. Let's complete it. 3 minus 3 cosine. Chow. Oh, that's cool. Okay, so here we go. I've got 2 graphs, one of which is r equals 2. That's our red graph. Probably should have written that in red. Nope, sorry. Blue graph. R equals 2. And I've got r equals 1 minus 2 sine theta. So let's say I want to find out where these graphs are equal, where they cross. At what measure for theta? What do you think I do with the 2 of them? What do you think I do? You can't use your calculator. Set them equal. Does this look like something maybe you've seen? Okay, if I subtract 1 from both sides, what do I get? Negative, oh, oops. I get positive 1. That's a positive. And that equals negative 2 sine theta. I divide by negative 2. Sine theta equals negative 1/2. Where is that true? Close. 3rd and 4th quadrant, right? So this point right here is theta equals 7 pi over 6. That point right there is theta equals 11 pi over 6. And look at that. Isn't that kind of cool? That triangle right there is a pi over 6 triangle. That's pretty sick. Draw triangle if you don't know what you're doing. Draw triangle, draw triangle, draw triangle. Cow, Gaines. $12 gift card GNC to anybody who subscribes and is the 100th subscriber. 200th subscriber gets a free training session from my 3-year-old on burpees. That be it.